count good nodes in binary tree. Given a binary tree root, a node X in the tree is named good if in the path from root to X there are no nodes with a value greater than X, or then the number of good nodes in the binary tree. Interesting. Here we have an example. 3, 1, 3, 3, 4, 5, 1. So output is 4. The root counts as well. Okay. Root node 3 is always a good node. Okay. 3, 4 is the maximum. If there are no nodes with a greater value than X. If 3, 4 is the maximum value in this path starting from the root. 3, 4, 5 is the maximum value in the path. Node 5, oh, okay. Node 3 is the maximum value in the path. Okay, and then we can have just the left subtree, no right subtree, 3, 3, 4. Oh, it has to be strictly, wait, hold on, what? 3. No value greater than X. No value greater than X, yeah. So in this path there's 3, 3, and 3, 3, 4. But to the path to 2, there's like a 3. There's 3's, which is greater than 2, so that path wouldn't work. Is there anything I can think of off the top of my head? Well, first of all, I guess I should ask clarifying questions. So root, can it be empty? How big can the tree be? The values in the nodes, I'm assuming they're integers and they can maybe be negative. Yeah, they can be, and okay, it can't be empty, it's 1, and the maximum number of nodes can be 10 to the power of 5. Alright. So how do we do this? I have to check each of the nodes, like make sure that each of the nodes has a good path. I don't think there's any way to avoid that. So at most I'd be checking, the high complexity at most, or at least it has to be n being the number of nodes. And then on each node you kind of do a recursive call, like I guess as you're going up the path, you make sure that the value that you're given is greater than or equal to. Like you want to make sure that 1 is greater than or equal to 3, which is not, and that's why it's not a valid path. And then for the 3, you want to recurse, bring it up here. 3 is greater than or equal to 1, and then over here you don't want to pass in the 1, but you want to continue passing the 3 all the way up there. That's all going to be a lot of recursive calls. I also don't know how, so I'm going to pass over the 3, so I'll need some kind of a helper method. And as I'm passing the 3 to the top layer, right, the path from the root to X, so you have to go all the way back to the root. How do I check that it's the root? I guess you don't really have to, do you have to consider that? I don't know. Well, I mean, I imagine the recursive call ends here. And then, Yeah. Man, how do I envision these recursive calls? They're always so annoying. Something with 5, 5, and then 5 all the way up there. What's the base case of the root? And yeah, 5, 5. You want to pass in the 1, pass in the 4 here, pass in the 1 from there. So from here you pass in the 4 and you also do recurse into the next, like its children. Oh, that's so interesting. How would I do this as a human? I like I'm doing it right now. I'm just starting at 3. I know this is a good node because the path from root to root is always good, just by definition. Then from I go into left and right. The left one, I know that 1 is not greater than or equal to 3, so this is not a valid path. I guess I'm also keeping track of the valid paths. So like the output at this point is 1, and then I also check 4. I can like recurse into 3, whichever. Like I guess we can go into 3. We go into 3. I'm like, okay, well let's look at the path to the root. So we have 1 and we have 3, and both of those values, right, they maintain that constraint of 3 being greater than or equal to the values in that path. So that's that's good. That's a node X. Yeah, so the node 3 is good. And then you want to do the same thing with 4, 5, and 1. How do I, so if I do a recursive call, well, I guess we would want to stop when there's nothing more to recurse. So if root not left, if not root not left, then return. If not root dot right, return. That's not right, because what if there's a root? No. Confusion. What if I just do if root, if not root, then return 0. That's not right either. Okay, we have the helper method that passes up, I guess, a Boolean check. At this stage is it true, at this stage is it true. And if you make it all the way to the top of the root, then you have done it. Uh, I'm also seeing repeated behavior, like we're doing 3 and 1. We're checking if 1 is greater than or equal to 3. And then we go from the bottom 3, like here, we check if 3 is greater than or equal to 1, and then if 3 is greater than or equal to 3. But at that second stage, we could technically check if 3 is greater than or equal to 3 and 1 is greater than or equal to 3 at the same time. We could do that. Okay, that's it for right now, because I'm running low on time. But yeah, not really good progress, but it is what it is. Okay.